About Bernoulli differential equation. Okay, and then in this segment, we're going to look at what is the form of Bernoulli differential equation, how do we solve it. Then after that, we'll take a series of questions, and those questions are very, very important questions. Some are past questions, some are from textbook. Okay, so let's go straight to the form. This of the form. First differential, the y, the x plus p of x, uh, y equal to q of x y prime. Okay, and then where p of x and q of x are constant function, are constant functions. Okay, constant functions. Note for Bernoulli equation, n is not equal to 0 or 1. N is not equal to 0 or 1. Okay? And n is what? N is a real number. N is a real number. N is, if n is 0 or 1, okay, the equation becomes what? The equation becomes linear. The equation becomes linear. Become linear differential equation. If your n is 0 or 1, then the equation becomes linear. The next thing we want to look into now, how do we solve it? How do we solve Bernoulli differential equation? Is y prime, y dx plus p of x y equal to q of x yn. Okay? Step 1 is solving it. Step 1, that will be equal to remove this one from here. Divide what? Divide through the equation. Divide through the equation. Divide through the equations by this one, yn. So if you do that, then you are having y prime over yn. And that will give you what? That will give you this one, okay, y prime plus p of x. Then here you're having y over yn in this case. And don't forget this one has the power of 1. So that will be equal to what? 1 minus what? 1 minus n equal to what? Here over yn. So that will be remain q of x in that place. Okay. Then step 2. Let v be equal to what? Let v be equal to that. Okay. And then differentiate that x. Differentiate implicitly x with respect to x. Because if you look at this v, okay, we want to differentiate that with respect to x, but this one is not an x function. Okay, so that means y is a function of itself, and at the same time it's a function of where we are going, dx. And that's why we are differentiating it implicitly. Okay, so and that will be equal to what? The v dx equal to what? Move this one to the front, and then this one here, minus 1, and that will give you 1 minus 1 cancel, then we have this, then the y dx. Okay, so then make this one the subject, so yn the y dx will now be equal to 1 over this the v dx. Once you make this one subject, you have this. Okay, so we can call this first one equation 1. Okay, then we can call this one star 1 star, and this one star 2. Okay, so substitute this one star 1 star 2 into this equation 1. Okay, so equation 1 becomes, put this one there, wherever you see y to power n, first differential, your y prime is the y dx, So, and that will be equal to what? That will be equal to 1 over 1 minus n dv dx, and then here plus